Hi everybody, this is Matt Morgan, and in this lesson we're going to talk about Wiley problem 13-091. That's from section 13-7. It's about acid hydrolysis and ionization. Let's look at the problem. So it says that solutions of sodium hydrogen sulfite are acidic. The first thing they want us to do is write the hydrolysis equation. Use the double arrow, don't include states. So the statement about the sodium bisulfite being acidic is important later. So one thing about this problem is that the sodium ion does nothing. This problem is all about the hydrogen sulfite ion, HSO3-. Also, this problem has a show hint button, and it's pretty useful. It says in a hydrolysis, an anion will accept an H plus ion. It confirms what we already know about hydrolysis. If you've seen the previous hydrolysis video, you know that a negatively charged ion is not going to do anything with OH minus. The negative charges will repel. And of course, hydrolysis is an ion reacting with either the H plus or the OH minus ion in water. This hydrogen sulfite will pick up an H plus from the water. You might remember this process from the hydrolysis video. We have the HSO3- ion, and it can react with either H plus or OH minus. The hydroxide ion will repel the negatively charged HSO3- ion. The H plus ion, however, will be attracted, and the result will be H2SO3. The HSO3- ion picks up an H plus from water, and we get H2SO3, or sulfurous acid. OH minus is also a product, which is why the process is basic. The reaction is HSO3- plus water in equilibrium with H2SO3 plus hydroxide. If we put this answer into Wiley, just as we did on the previous slide, making sure to use our double arrow, we see that that answer is correct. Now let's move on to the next part. They now want us to write the ionization equation, double arrow and no states. Now, ionization occurs when a compound breaks up into its component ions. And once again, we're looking at the hydrogen sulfite anion. There's also a hint button here that's kind of helpful. In the ionization of an acid, H plus ion will be donated. So hydrogen sulfite is not very acidic, but it can give up an H plus. That reaction is HSO3- in equilibrium with H plus SO3 2-. Pretty straightforward. The acid breaking up into its ions. However, if you enter this equation into Wiley, they're going to mark it as incorrect. So let's talk about that. In other textbooks, you certainly will see acid ionization written just like this. We've got our acid in equilibrium with H plus and the conjugate base. The Wiley textbook, however, doesn't like H plus ions, and I can kind of see where they're coming from. It's a subatomic particle. It won't just float around. It's going to combine with something like a water molecule. So H plus by itself, bad. Wiley's looking for H3O plus. And when water is our solvent, H plus and H3O plus, same thing. And in Chem 2 acid-base chemistry, water is always going to be our solvent. So our ionization then is hydrogen sulfite, H2SO3- going to H3O plus the sulfite anion. To make the equation balanced, we're going to put a water on the left-hand side. So that gives us H2SO3- plus water going to hydronium plus the sulfite anion. That's what Wiley is looking for. Let's check it out. Okay, bisulfite, water, double arrow, no states going to sulfite, hydronium. The order, if you put hydronium first or second, doesn't matter, as long as you have them both. And that is correct. Okay, final part of the problem. Which takes place to a greater extent? Now, just looking at the hydrolysis and the ionization, we wouldn't know what takes place to a greater extent. But they did give us some information at the beginning of the question. They said aqueous solutions of sodium hydrogen sulfite are acidic. That's our key word right there. Hydrolysis gives us OH minus ions. There's the hydrolysis reaction again. Ionization produces hydronium. The given information says the aqueous solutions are acidic, so the ionization takes place to a greater extent. This is just applying the given information, kind of a common sense thing. Let's put that answer into Wiley. Okay, ionization, and that is correct. So, ionization and hydrolysis are different, although they look very similar, especially in the case of ionization of acids, with Wiley wanting the hydronium in the water. It looks like water's reacting both times. So, with this concept or any others, please contact your course mentors if you have any questions. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.